Hello again, everybody. I hope you're having a good day today. And I'm back here with another example of the rolling motion, no sliding. But I've already done this problem for you with the same numbers using the relative motion approach. Now I want to show you how we can use the IC method, the instantaneous center, which is the shortcut actually, and hopefully this will make much better sense in terms of the motion, and you'll see how easy it is actually to use this method to do problems. So remember, rolling motion, no sliding. So in this case, we are given the angular speed omega to be 8 radians per second clockwise, and then radius of this guy is 10 inches, right? And what we want to find is velocity of A, velocity of B, velocity of C, and D. A is the center, B is right above it on the rim of the wheel, and then D is right on the right-hand side on the rim, and C is the contact point. Now, whenever you have rolling motion, and remember, this only works for rolling motion, right? The instantaneous center is always the contact point. And the way you justify that, by the way, remember the IC is the point where if you could find on a rigid body that is going through combination of translation and rotation or general plane motion, if you could find a point for which the velocity is 0, then that point must be the instantaneous center. In this case, the contact point, you see this point on the surface here, on the stationary ground, stationary surface, has 0 speed. So when this wheel comes in contact with it, right, it should have the same point. When two bodies are in contact like two gears, right, at the contact point, it should have what? The same speed, for example, right? The same velocity. So in this case, point C in contact with the stationary point on the ground should have the same speed. Therefore, C becomes the instantaneous center and velocity of C is 0. Once velocity of C is 0, right, then that becomes like a pivot point, right? So now finding velocity of different points on the body at this instant is very easy. And the way you do that is very simple. So for example, you want to find velocity of A, that would be R omega. R is from what? The instantaneous center to the point CA times omega. So that's 10 inches. And remember that velocity, since we have no pure rotation, right, would be 90 degrees to that radius. Similarly for point B, R omega again, but now you're talking about CB. So connect from C to B, and CB is 20 inch, the diameter of the wheel, and then see that velocity would be also 90 degrees to the radius from C to B, right? And then that would be actually twice as large. These are inches per second, by the way, right? And guys, this is, by the way, the case that we were talking about. Let me make this more to scale. Remember in one of the videos I said that if you have two velocities that are parallel to one another and they have different magnitudes, this is velocity of B, you can connect those 2 points together and extend, and then connect the extremities of them, and look where they intersect. They intersect at that point, which is the instantaneous center. So basically velocity is proportional to the radius, and that's what we have here. This is twice velocity of A. All right, now next, let me actually find velocity of D for you. So same story. Velocity of D is R omega, CD times omega. CD, if you go ahead and calculate the distance from C to D, that's easy. This is C, this is D. This is 10 inch, radius 10 inch. This becomes, I believe, 14.14 inches, 10 root 2. Okay, times 8 omega, so we get 113.4. And how would that velocity look like? Connect from C to D, and that velocity has to be what? 90 degrees to this radius, CD, right? and that makes the angle 45 degree. So you see now, we've already done this. Go ahead and check this versus, the relative motion that I have it in another video. And you see these are exactly the same numbers we got for velocity of different points. By the way, for that, you can find velocity of any point then. So for example, let's say if you want to find velocity of this point, say point E, what do? You just connect from C to E, and that velocity would be CE times omega, and that velocity would be what? 90 degrees to what? To this radius. Okay? So I hope this you see that this is a much easier shortcut in a way approach to figure out velocities for what type of problems? Bodies that are in combination motion. Combination means part translation, part rotation, or also known as general plane motion. General plane motion means bodies that are translating and rotating at the same time. Again, thank you for watching and listening.